Welcome back to Mr. DuPage's classroom. This is a lesson for my CP Algebra 1 class. This is 2.7, day 2. This is dependent events. Now, dependent events has to do with our probability lessons that we've been working with. It is the next lesson after our independent events that we just talked about the other day. Make sure your date is up in the top right-hand corner, and let's begin. Dependent events are the opposite of independent events. So a dependent event is going to be events that do influence each other. If you remember, independent events are events that do not influence one another, and independent events are when we will have replacement. So if dependent events are the opposite of that, they will be without replacement. They would be without replacement. Okay? Let's get into our formula. Probability of two dependent events. If A and B are dependent events, what is the probability of A and B? Well, in this case, it would be the probability of A times the probability of B given A, which basically just means what is the probability of B after we get rid of A. But that is said as the probability of B given A has occurred. Okay? When we did not replace the tiles in the first experiment, we were dealing with two dependent events. Two dependent events. Okay? Other dependent events. Using the same tiles from our second practice problem, that was on our independent events. What is the probability of choosing an A the first time and an E the second time without replacement? So the probability of A, we just need to find out how many A's there are. Well, there are 1, 2, 3, 4. So there are 4 A's. How many total items were there? The other day we found out there were 15 in these tiles, so it would be 4 out of 15. So what is the probability of E after A? Well, I'm going to get rid of one of these A's. So how many total tiles do I have now? I have 14 total tiles. How many E's are there? 1, 2, 3. So it would be 3 out of 14. So what are we going to do with those two fractions now that I have them? Well, to find out the probability of A and then E, I'm going to go ahead and take 4 out of 15 times 3 out of 14 and find out what the probability of A and then E would be. In this case, 4 times 3 is 12. 15 times 14 is 210. That can be simplified to 2 out of 35. All right, let's keep rolling. So we're going to try number 1. Using the same tiles, find the probability that you will choose a U and then an O without replacing the first tile. So the first thing we need to find is the probability of the U. What is the probability of U? Well, how many U's are up here? There are 1, 2. There are only 2 U's, so that would be 2 out of 15 because there's 15 total tiles. Then I need to find the probability of O given U. Given I have already pulled a U. So that would be 4. There are 4 O's. 1, 2, 3, 4. Out of 14, which that can be simplified to 2 out of 7. So what is the probability that U and then O are pulled? Well, the probability would be 2 out of 15 times 2 out of 7. 2 times 2 is 4. 15 times 7 is 105. So our probability of U and then O is 105. That's without replacement. Now let's look at a teacher must select 2 students randomly from 3 freshmen, 2 sophomores, 4 juniors, and 4 seniors. How many total students is that? Well, 3 plus 2 is 5. 5 plus 4 is 9. 9 plus 4 is 13 total students. What is the probability that a sophomore and then a freshman are chosen? So basically what this means is if I just had sophomores and freshmen in the class, I'm going to choose one sophomore to go out in the hall, and then I'll choose one freshman to go out in the hall. Okay? So they would no longer be in our within the ability for me to choose that same sophomore again. So the probability of a sophomore would be 2, because there are 2 sophomores. It would be 2 out of 13. That is the probability of a sophomore. What is the probability of a freshman? Given, it's the probability of a freshman given a sophomore was polled. Well, there were 13 students originally. If I polled 1 student, there would be 12 left. How many freshmen are there? There are 3 freshmen. Well, that'd be 3 out of 12. Well, 3 out of 12 can be simplified to 1 out of 4. Okay? So now to find the probability that I pull a sophomore and then a freshman, it would be 2 out of 13 times 1 out of 4, which would be 2 out of 52, which can be simplified to 1 out of 26. All right. What is the probability that a sophomore and then a junior are chosen? So first is the probability of a sophomore. Well, we just learned that right up here. So it would be 2 out of 13. What's the probability of a junior being chosen? Probability of a junior being chosen is going to be 4 out of 12. I'm sorry, that is a junior given a sophomore has been chosen. Given that a sophomore has been chosen. So there were originally 13 students, now there are only 12. There are 4 juniors. That would simplify into 1 out of 3. So in order to find out a sophomore and then a junior without replacement, it would be 2 out of 13 times 1 out of 3. So it would be 2 out of 39. It would be 2 out of 39. What is the probability that a junior and then a sophomore are chosen? So I'm just going to flip which one is chosen first and which one's chosen second. So it's the probability of a junior would be 4 out of 13. Then it's the probability of a sophomore given a junior has been polled. Well, that would be 2 out of 12, which would simplify to 1 out of 6. I would multiply those two together, so 4 out of 13 times 1 out of 6 would be 4 out of 78, which can be simplified into 2 over 39. The next question says, does the probability of choosing without replacement change if the order of events is reversed? Well, look at B and C. I flipped which one came first. Did that change my probability? Well, it was 2 over 39 here. It was 2 out of 39 there. So no, it does not. We would have the same overall probability. The big thing here is to remember that if you are looking for the probability of the first event and then you do not replace that first event, then to find the probability of a second event, you need to lower the overall number of events that are possible by 1 and then go ahead and multiply those two probabilities together. If you understand that and understand that dependent means we're not replacing things, then you will do fine after this lesson. Thank you very much for watching and have a great day.